Hello and welcome to Lagares Corporations. This is Christian Lagares. First of all, what do we know of our world? Well, we know that we're pretty small in comparison with the rest of the universe, and we don't have much resources in comparison with the vast space and energy needs that we have. And we are clearly starting to get a lot hotter with every day. Here in this plot, thanks to Nat Geo, you're seeing a plot of the current world warming since 1960 through 2014, so it's pretty recent data. We see the top part of the plot, where it's a little bit dark. Those are 15 degrees Fahrenheit hotter than in comparison with 1960. And what does this mean for all of us? Well, it means that the ice caps are most likely starting to melt, which means that less and less and less space is available to absorb this heat, and more water is starting to be displaced to other places of the world. Soon to be is the disappearance of islands, especially those that are in a relatively low altitude relative to the current sea level. And other areas in the world are starting to see high concentrations of pollution in the regions. Currently, we are building, well, we think that we're building for a lot of things, but actually we are building for disaster. This image that you see right here is a nuclear generation power plant, which may seem as a clean energy alternative, but it presents a lot of waste management issues from the engineering side. This image corresponds to cooling towers of a coal burning plant, and we're building for a disaster. Everything that we design, every single prototype that we make, does not take into account global warming and its consequences, at least not until now. So how do we define disaster? Well, carbon dioxide emissions have increased from less than 5,000 teragrams. Those are 5,000 trillion grams in 90 through 1940 to over 30,000 teragrams after the year 2000. That's a lot. Those are 6 times more grams of carbon dioxide emissions when compared to pre-World War II conditions. Thanks to the global, regional, and national fossil fuel CO2 emissions, we see here the increase in a plot per year. So we see that in around 1960, we just plummeted up. We just rise every single year, and it doesn't seem to stop. This other plot we see right here, we see the distribution of contaminants in global greenhouse gas emissions by source from fossil fuel and other industrial processes. And we see that China is at 23%. Considering that they have the largest population in the world, that shouldn't be very surprising. But the United States, that is not even second to China in terms of population, is 19%. The European Union, excluding Estonia, Latvia, and Lithuania, 13%. 6% India, 6% the Russian Federation, 4% Japan, Canada at 2%, the remnant countries at 28%. From these, we have only from fossil fuel use 57% of emissions. From deforestation and decay of biomass, 17%. Between those two, we have more than 2/3 of the greenhouse gas emissions. And I like to make a stop here on deforestation and decay of biomass to explain a little bit of what that is. When we throw down trees to open space for new constructions, we free up stored carbon dioxide that the trees have. So imagine a whole forest being torn down. The amount of carbon dioxide that is released in just an instant. And by decay of biomass, we have a lot of resources that are currently unused, which is biomass. In a recent study, the United States has the largest deposit of oil shale, which is a type of biomass. And this type of biomass, if not used, decays really fast when compared to other fossil fuels. Now, where are we going? Well, I'm very proud to tell you that Lagares Corporations looks forward to this. Moving forward to hydroelectric power generation, solar power generation, and wind power generation. And why? Well, I'll take a minute to explain why each of these can help us make a brighter future. Wind. Right now, General Electric is developing, or leading, I should say, a global revolution in this type of resources. Intelligent machines powered by next generation data and computing platforms will lead us to intelligently gather energy. How can we intelligently gather energy? By realigning wind turbines and solar plants, and by adjusting water flows on hydroelectric plants. And we're capable of maximizing and optimizing energy resources by simply realigning where are we focusing our resources. It's that simple. We truly exist because of you. Lagares Corporations is a consulting firm that looks forward to develop your business, help you prototype new solutions on energy consumptions, and help you in taking into account the environmental impact when designing new products with humanity's future in mind. We're developing a better future. Why? Because prototyping solutions just got a lot cleaner. You really don't have to worry. You don't have to build it to see it. We provide virtualization techniques. What is that? We help you see your designs implemented even before they're implemented on a digital scale. You can have cleaner and energy efficient simulations without using extensive computing power. And we will work with you to make your business a solid business for tomorrow, since today. How? By using cutting-edge technology like eco-friendly 3D printing and low-power prototyping. These techniques are the techniques being used on Tesla motors, on NASA, and global powers leading tomorrow's revolution. We can build a better future together. Join me in making the difference. Thank you. Reference information for today were gathered from IPCC 2007, based on global emissions from 2004. Details about the sources included in this estimate can be found in the contribution of Working Group 1 to the 4th Assessment Report of the Intergovernmental Panel on Climate Change. Source of the data presented: Bowden T.A., G. Marlin, and R.J. Andres, 2010. Global, Regional, and National Fuels CO2 Emissions. Carbon Dioxide Information Analysis Center, Oak Ridge National Laboratory, U.S. Department of Energy, Oak Ridge, Tennessee, USA. Source: National CO emissions from fossil fuel burning, cement manufacture, and gas flaring, 1751 through 2008. Thanks to the National Geographic staff. Sources: Stephen Mosher and Robert Rode, Berkeley Earth. Thank you for joining me today.